The three themes we care about as far as our portfolio is concerned right now are computer vision, CRISPR technology, and blockchain technology. There is other ideas that we're working on, particularly space. We don't have exposure to that particular sector right now in our portfolio. This is Not Even Wrong podcast. It's July 8, 2021. This is Krim Delco. Since the last update, we are up about 70 basis points. For the year, we are now up 30 basis points. The market is up 15.5%. We're underperforming by 15.2%. This is kind of like a summary episode, just to come back to the fundamentals of what is it we care about, what is it we are in particular looking at as far as Orange Capital Partners is concerned. And the answer to that question is there are three themes that we are looking at right now. One theme is computer vision, one theme is CRISPR technology, and one theme is blockchain technology. I want to talk about those three themes. And just before I go there, I just want to reiterate, this is a lot more important than it might sound. This is not just some sort of bullet point summary. This is our agenda. This is what we do right now. If I wake up in the morning, those are the things I care about the most. Doesn't mean I continuously read and work on these themes, but when I see an article, let's say in a news outlet that covers one of those three themes, then that's where I'd be mostly interested in reading and spending my time with. I go to conferences, I talk to people, I talk to academics, I talk to business people about those three things. So let's start with computer vision. Computer vision is the underlying technology that enables self-driving cars. This is the view that Tesla has. This is the view that we have. We absolutely agree with that. We are willing to take that risk. We are willing to take that leap of faith that just solely with vision you can solve self-driving. Now, that entails a couple of things that, in my view, are key. Number one, computer vision as a standalone technology is very, let's say it's a very interesting technology. It allows for a lot more than just self-driving cars, of course. What it is fundamentally, computer vision is the ability to analyze bits and then turn them into some sort of meaning in a spatial context. In a spatial context means there is something which looks like a tree. I should not bump into that tree. There is a pedestrian. I should not bump into the pedestrian. There is a car, I should take over that car or let that car pass, etc. Those are the things that I think are crucial when it comes to computer vision. What have we done as far as educating ourselves in that space? Well, I've attended a bunch of lectures, starting with the machine learning lecture that Andrew Ng started probably about almost 10 years ago now on Coursera. I've done an audio course on Coursera. I've done the self-driving car course on Udacity, and I've done several other shorter courses on OpenCourseWare at MIT to educate myself in terms of how to apply computer vision, in particular for self-driving, but also for other technologies. So in general, what is machine learning? How is it being used? And more specific, practical, how can it help self-driving car technology? The conclusion of all this, and in tandem with what we're hearing from Tesla and other industrial players, is that it's worth a shot. It's worth a shot because if it works, it's scalable. That's the big difference between the Tesla approach and everything else. If vision works, it's scalable. If it doesn't work, probably everything else will also fail, and we just have to wait for another breakthrough, whatever that may be. If the breakthrough is going to be some sort of new machine learning technique, if the breakthrough is going to be something along the lines of maybe new algorithms, or if it's just a hardware question, or if it's a transformer question. So we just need something like GPT-3 or something like that for vision, which actually exists. I forgot the name. So the fundamental thesis here would be, look, we can just super train things. We can just super train the adoption of data analysis in this particular way, so we can then use the learnings from this transformer to actually turn that into some useful technology. This is possible. Again, I don't know, maybe Tesla will do that with their Project Dojo. I don't know. I'm very open to any kind of situation, any kind of a solution, but I think that Andrej Karpathy and his team under Elon Musk have a shot at this because they have the data, they have the fleet, they have the technology to use the fleet in a useful way, and they also have the approach and the mindset. I think those are the things that I think will work. So this is the big thing, theme number one, computer vision, driving, self-driving, and therefore a complete monopolization of what we call the automobile industry today, and I would call the transportation industry tomorrow, or in general, just the problem of getting from A to B, localization, whatever you want to call it. This problem can be solved with vision and then using hardware such as a Tesla or whatnot in the future to solve that problem. Number two, CRISPR technology. I think the fundamental concept here is not just CRISPR, it is digitization of life sciences. What do we mean by that? Digitization of life sciences means that we are going from a bespoke system of try and error to a first principle, bottom-up approach of using digital technology, the same way we're using digital technology within the computer science space, we can use that within the life science space. And CRISPR is the crucial tool for that because it allows the editing of the genome. So we can have basically a programming language based on CRISPR that helps us program the genome, and we can go from there and learn about how to actually, let's say, develop pharmaceuticals, how to cure diseases, how to analyze diseases. By the way, this goes both ways. So we can write genetic programs with CRISPR into the DNA, but we can also go the other way around and try to understand, let's say, diseases such as Alzheimer's based on the ability to manipulate the genome. For example, this is one of the things where Alzheimer's research has the ability to make huge leaps, which is the so-called pluripotent cells, so the stem cells that are turned into some stem cells, and then you can then see how if you, let's say, use, I don't know, a million cells, and each cell has a different mutation that is induced by CRISPR, and then you can see the effect and maybe find correlation between the effect and Alzheimer's, and therefore sort of do this brute force approach of trying many million types of different mutations within cells to see which one actually has some sort of efficacy when it comes to Alzheimer's, and then go from there and try to understand the disease and then find cures. So again, it goes both ways. You can design from the ground up, or you can deduct from what you see from the phenotype how the design on the ground should be. Both ways, very interesting. Of course, I've also mentioned the protein folding breakthrough with AlphaFold, which you could then, if you want, go even further and say, well, we have not just the DNA is kind of the database, which the source code, but then from there we can go into the ribosome and the protein. So it's DNA and then ribosome protein, and since we know how from the amino acid structure proteins might fold, thanks to AlphaFold, we can then go DNA, ribosome, amino acid structure, folding, function. So DNA, function, one big leap. Of course, this is still early days, but we have the technology, we have the first steps of technology, and therefore the digitization of life sciences could get a huge boost. We believe that over time this could be a much bigger market and generate a lot more wealth for us than actually even the other, the computer vision side of things. But right now, computer vision is a bigger part of our portfolio. Third, blockchain technology. I think here the fundamental breakthrough is that Bitcoin has solved the Byzantine generals problem. It has solved the problem of how to communication over a decentralized network and still make sure that the data is correct. As a consequence, we have a digital currency called Bitcoin, but much more importantly, we also have the ability here, and this is what's really so exciting, we have the ability to generate smart contracts on the Ethereum blockchain. We have the ability to superimpose decentralized decision-making, decentralized record-keeping, decentralized money, decentralized almost anything which today is organized by governments, and the law can be decentralized and put on the blockchain. And this is what we are so excited about here. So a decentralization of power, because having the power to decide what is a fact, having the power to decide what is happening and what is not happening is really what power is. And that, of course, gives us a lot of hope that we can find interesting new technologies, interesting new economic ways to take advantage of those technologies. So those are the big three things. Again, computer vision, driving, self-driving. Number two, CRISPR, digitization of life sciences. And number three, blockchain technology, decentralization of power. The last thing I want to mention is that we are also looking at the space industry. The problem with the space industry is now in SpaceX, there's nothing interesting right now for us to invest in. There's a few startups we've looked at, for example, a company which does propulsion in space, another company which does microsatellite launching to ride sharing. So there are interesting aspects that are enabled through SpaceX, but we are still in early days for that. So I think the focus will be on the first three as far as our investment approach is concerned: computer vision, CRISPR, and blockchain technology. Thank you.